Hello everyone, welcome to episode 11 of Reconstructing Case Story. In this episode we're going to be working on creating a test map, but before I get into that, there's a couple of cleanups I want to make. There's an important one and kind of a trivial one. We'll start with the important one, which is this SDL delay call that we're making. So right now we're doing 1,000 milliseconds divided by the number of frames per second, and then subtracting from that elapsed time in milliseconds. But what if elapsed time in milliseconds is greater than 1,000 kfps? And if we look at SDL delay, I'll look at the man pages for that, SDL delay. It takes in a uint32. So this means that it's only going to take in a positive number. And if it gets a negative number, it converts that negative number into a very, like if it's a small negative number, it converts it into a very large positive number. And as a result, instead of getting zero delay, which is what we would want in that situation, we would get a really long delay. And so we need to fix that. We can think of this 1,000 milliseconds as being divided by the frames per second as being the milliseconds per frame. And then I want to make a trivial change, which is just moving this SDL show cursor into the graphics class. And that's just so that we kind of keep the graphics logic all in the graphics class and out of the game class if we can. So yeah, I'm going to do that real quick before we get started. So I'll go into the game CC file and let's start with the SDL delay. Right, so I'm going to break out this 1,000 divided by kfps into another constant since we're going to use it in two places. And this will be milliseconds per frame. And that'll be that value. And so we only want to do this SDL delay if elapsed time in milliseconds is less than milliseconds per frame. So we'll just add that check in here. And that should be good. I'm going to run it real quick just to make sure that I didn't do the wrong if statement and everything looks fine. And then another really quick change is just moving this SDL show cursor, which is in our game constructor, over to our graphics constructor, right below where we create the screen. And I'll make sure this is all running, and it is. So now we can get back into the actual episode. So let's begin episode 11 proper. In this episode we're going to be creating a test map. All we want to do at the end of this episode is just have a map of walls and collision rectangles that are drawing to the screen. And we're not going to be able to run into them or jump on or jump off of them yet, but this is all in preparation for collision detection, which is going to be the next few episodes. So for the actual implementation, we're going to have a map class, which is for now just going to hold, this will be a vector of vectors of foreground sprites, and that's just because sprites don't hold their XY coordinates, and so we need to have some way of knowing which row and column to draw them at. And that's going to be the first dimension of our vector of vectors is going to be our row, and the second dimension is going to be our column. And it's also going to hold a collision map, and that's just going to be a collision map object. And this collision map is going to, for now, just hold a list of collision rectangles. And we'll start using more of the collision map later and filling out some more methods. But I'm going to go ahead and abstract it out into another class now, just because I know it's going to need more later. And we're just going to create our test map before the event loop. It'll be a private member data of game. And this is just a temporary thing while we start working out collisions. But we're going to be getting into dynamically loading levels in game later on. So yeah, let's get started with the map class and drawing sprites to the screen. So let's open up a map class and give it the usual header guards. I'm going to start with the foreground sprites. And these are going to be a double array or double vector of boost shared pointers to sprites. So it's just going to be a nested vector, a standard vector of boost shared pointer of sprite. So that's a lot of modes, but we make do. Space. Okay. So now we need to include vector and shared pointer. Boost shared pointer.hvp and forward declare sprite. We're also going to need, because we need to draw and update all of these sprites, we need a draw and update method for our maps. So it's going to be void update. It'll take elapsed time in milliseconds. And a draw, which will take in a graphics reference and which will be const. So it'll be struct graphics as a forward declaration. Yeah. So I'm going to go ahead and create a map.cc file to flesh these out. Source map.cc, include map.h, include sprite.h, and include graphics.h. Okay, so for updating and drawing, we're just going to do a loop over these double vectors, and it's pretty simple, straightforward stuff. Let's scope these in now and give ourselves some curly braces. So we'll start with update, and update is just going to say for size ti equals 0. Oh, no, let's do row equals 0. Row is less than foreground sprites dot size, and then we'll do row plus plus or plus plus row. And we're assuming that foreground sprites is going to be of the correct size. That's one of the assumptions we're making right now, and we can actually enforce this when we start working on the constructor for the object. And so we do the same thing for columns, except instead of row, we say call, so we replace row with call. And then instead of foreground sprites.size, we say foreground sprites of row.size, because we want to get the length of a row to get the number of columns in a row. And this is a rectangular grid, so we can make the assumption that all rows are the same size. And all columns are the same size too. So for this, we need to see, does the foreground sprite exist? And we can just do this with a simple if check. If it's existing, then we update it, passing in the elapsed time. And the same kind of logic for drawing. So I'm going to copy and paste everything. Only instead of updating, we're going to be drawing. Oops. Go away. Move. There we go. We're going to be drawing. And again, this is only if the foreground sprite exists. So draw, giving it the graphics. And now where are we going to draw it at? It's going to be at call times the tile width, which means we need to include game up here at the top, and row times game k tile size. Because remember, this this over here is x, and the calls are measured in x, and rows are measured in y. So we got to switch these. Kind of tricky thinking, but you get used to it when you do it a lot. All right, let's see if there's anything else. I'm going to make sure that this compiles. It does compile. So now we need a constructor, and what I'm actually going to do is, because later we're going to construct it from a map, or from a map file, but for now we want to be able to have a test map that we can just call the constructor for in our game class so that we can have a test map to work with until we actually want to spend the time to parse out a binary file. So I'm going to create a static method that returns a new map, and it will be called create test map. And it's going to actually create the sprite too, so it's going to need a graphics reference in addition to, well, nothing. Not in addition to anything. Okay. So let's define this up here. And right now I'm just going to return a new map. We'll put it to do. Because I just want to get it compiling right now. So let's make sure this compiles. It does. Now that we have that compiling, let's actually put it in our game class and get everything hooked up over there. So we're just going to have it be in a scoped pointer, kind of like the player, except it'll be called map, and it'll be a type map. So let's forward declare that too. Now in the CC file, we have to create our map. So we'll do map.reset, and we'll call our map, well, let's include map first. But when we reset it, we'll reset it with map, create test map, passing it in graphics. Alright, now we have two methods in map, update, which we'll just arbitrarily throw underneath player update, lapse time in milliseconds. And then we also have draw, and I'm going to do it after our player draw and not before, because if we do it before, the map tiles will get drawn to the screen and then the player will get drawn on top of it, and that's not what we want to have happen. We want these foreground tiles to be drawn on top of the player. So I'll just put map draw, passing it in graphics. So I'm going to run this to make sure that this is still working, and it is, which is wonderful. But we don't have a map to look at yet. So let's go ahead into our map CC file and actually fill in this create test map. So instead of just returning a new map, I'm going to store a map inside of the map variable and then return that. So what do we need to know about our map? So let's start with the number of rows. So number of rows equals, it's going to have 15 rows because this 15 times 32 equals 480. And number of calls is going to be 20, because in much the same way, 20 is 640. And so this is just our screen width and our screen height, and that's how I'm getting these numbers. So what I want to do is I want to have just a row of tiles underneath quote where he's walking. So that's going to be in the 11th row. So I'll just say constant row equals 11, and it'll be all of the columns. So for call equals 0, call is less than none, calls plus call. Okay. So before I start putting sprite into our foreground, so I'm going to do something like maps foreground sprites row call. We need to create a sprite, and we need a sprite file with tiles we can use that look like a map. So I grabbed the portcave.bitmap, and if we look at this, this is just a, if we look at this, zoom in, these are just 32 by 32 tiles, and they're just all of the first cave's sprite map. And we're going to just use this sprite up here, this 32 by 32 area, because it's very easy to tell it's a square sprite. And it'll be easier to see the edges and stuff. Anyway, yeah, so that's what we're going to use. So close that. So our sprite is going to be a shared pointer, and instead of saying boost, I'm going to bring in a using statement. So boost shared pointer, just to make it easier on myself to type sprite. We'll call it sprite, and we'll initialize it with a new sprite, passing it in graphics. This is what we need our graphics for. And we'll pass it in content portk.bitmap. And it was the second tile over, so we need to use game k tile size. And it was at the top row, so 0. And it was tile size by tile size in size. So now we have our sprite. We're almost ready to, hold on, one more parentheses. We're almost ready to actually fill in our foreground sprites. But as I said before, we actually need to make sure foreground sprites is of the right size. So in order to do that, I'm going to reconstruct the foreground sprites to make sure that they are the correct size. So we'll use a constructor for, also going to scope in standard vector, just to save some more typing. So we're going to use vector of shared pointer of sprite. I'm going to construct it with num rows, and we're going to construct num rows, that's the number we're going to be constructing, and we're going to construct it with this value, and this value is a single row, and a single row will contain num columns, and each column, row comma column, is going to have a shared pointer sprite initialized with no pointer. So this is just to ensure that foregrounds, ensure foreground sprites is num rows by num calls in size. We don't want it to be bigger than that, and we don't want it to be smaller than that. So that's how we're going to ensure it, and we just won't change the size later. So now that we have our foreground sprites initialized, let's go ahead and fill it. And this is going to be filled with, thusly, a row call. We're going to just put sprite in. So hopefully this makes sense. We start by creating a new map. Now we're defining num rows, num calls. Now we make sure that foreground sprites is the size of num rows and num calls. Then we create our sprite from the new bitmap that I showed you. And then we're going to be placing everything at row 11 and looping through all the columns and just putting sprite into foreground sprites. So yeah, let's check this out, make sure it works. Yeah, and here we have our row of sprites all on the bottom. Now we can add a couple more sprites just to make this map a little bit more interesting. And I'll show you how to do that. That's just as simple as, like, let's say I want a foreground sprite at row 10. I'll make like a staircase, and so this will be column like 5 or something. And then row 9, and this will be column 4. And let's do another one, say right there. And it'll be, instead of that, it'll be 10, just so it'll make like a little hole to jump into. Okay, let's see how this looks. Yes, and I'd love to be able to jump into these, or onto these, but I can't do that yet. Anyways, guys, thanks for watching.